The vacuum of space is not empty. It has a structure. The laws of physics, the forces, the particles, the behavior of matter, all emerge from a property of space itself called the quantum field. And our universe, as best as physicists can currently determine, may not be sitting at the lowest point of that field. It may be sitting partway up. This is called a false vacuum, a region of space that appears stable, that has sustained matter and energy and the laws we know for 14 billion years. But that is not at the lowest energy state that space is capable of occupying. The analogy physicists use is a ball resting in a shallow bowl on the side of a hill. It sits there. It appears stable. Nothing is threatening it. But the bowl is not at the bottom of the hill. There is a lower energy state available. Given enough time or the right perturbation, the ball could escape the bowl and roll down, and everything changes. The Higgs boson, discovered in 2012, gave physicists a precise way to measure where our universe sits in this energy landscape. The mass of the Higgs boson determines the shape of the field. The calculations, refined with improved measurements over the decades since, put our universe uncomfortably close to the boundary between a stable vacuum and a metastable one. Not definitively unsafe, but not definitively stable. What happens if it decays? Somewhere in the universe, it does not matter where. A quantum fluctuation nucleates a small bubble of true vacuum. Inside that bubble, the laws of physics are different, fundamentally different. Atoms as we know them cannot exist. The forces that hold matter together do not function in the way they do here. The bubble expands outward at the speed of light in every direction simultaneously. There is no way to see it coming. There is no way to stop it. The boundary of the bubble travels at precede, which means information about its approach cannot precede it. It arrives at the same moment it is first detectable. There is no warning. There is no experience of it. There is the universe as we know it, and then something else, with different laws, incapable of sustaining what we are. This process is irreversible. The bubble does not slow. It propagates outward forever, converting all of space into a region where the physics we know cannot exist. It does not destroy the universe in the conventional sense. It overwrites it. The unsettling part is not that this will happen. It may never happen. If our vacuum is only slightly metastable, the timescales involved would be so vast they make the current age of the universe seem like an instant. The unsettling part is that there is no way to know whether it already has. A bubble could have nucleated billions of years ago, somewhere on the other side of the observable universe. It could be expanding toward us right now, at the speed of light. We would not know until it arrived. We would not know at all. The physics that allow us to exist would be gone, not ended, replaced.